And now let's begin lesson 2, functions and function notation. Functions are written using function notation. To write a function using function notation, substitute the dependent variable with f of x. So if you want to write a function in function notation, simply substitute the dependent variable, which is usually y, with f of x. F, any letter can be used in place of x, is used to denote a function, and x represents the independent variable in the function. The value of the independent variable being used in a certain case replaces x. So whatever value you have for an independent variable, that's going to replace x. So f of 4 is the value of a function when the independent variable 4 is being used. Let's look at an example. So 4 is being used as the independent variable, so it replaces x. So we have f of 4. So looking at our example, y equals 3x plus 10. First replace the dependent variable, or y in this case, with f of x. So the first thing we do is replace the dependent variable, y in this case, with f of x. And we get f of x equals 3x plus 10. Now we can find the value of the function for any value of x by simply substituting x for x for the independent variable. What is the value of the function when x equals 3? Simply substitute 3 for every x in the function. Note that 3 in brackets means that the independent variable 3 is being used. So we substitute 3 for every x in the function in order to determine the value of f at 3. So f of x equals 3x plus 10. Substitute x equals 3. The independent variable 3 is being used. So we substitute 3 for every x in the function. F of 3 equals 3 times 3 plus 10 equals 9 plus 10 equals 19. As a result, you can find the value of any function for any independent variable by simply substituting the value for x in function notation. When a relation is given as a set of ordered pairs, the information can be organized into a mapping diagram. In a mapping diagram, domain values are placed in one oval and range values in an adjacent oval. Arrows are then drawn from the domain values to their corresponding range values. So in a mapping diagram, we have the domain values in one oval and the range values in an adjacent oval. And then we have arrows drawn from the domain values to their corresponding range values. A relation represented through a mapping diagram is a function if only one arrow leaves each value in the domain. So a relation shown through a mapping diagram is a function if each value in the domain has exactly one arrow and only one arrow leaving it. If 2 or more arrows leave any value in the domain, the relation is not a function. A value in the domain has more than one corresponding value in the range. Let's look at a mapping diagram and interpret it. So here we have the domain values and the range values. The domain values being on the left, the range values being on the right. We notice that we have 2 arrows from -1 to 3 and 4, and 2 arrows from 1 to 1 and 2. So because we have 2 arrows coming from one value in the domain, that means that one value in the domain matches with at least one value in the range. Therefore, this is not a function. Since the domain values x equals -1 and x equals 1 correspond with more than one value in the range, the relation is not a function. The set of ordered pairs proves this. -1, 3, -1, 4, 1, 1, 1, 2, 2, 3, and 4, 3. Since the x values x equals -1 and x equals 1 correspond with 2 y values, the relation is not a function. So because -1 corresponds with 3 and 4, and because 1 corresponds with 1 and 2, this means that we have x values that correspond with more than one y value, or more than one value in the range. This means it is not a function. Function notation can also be written in another way, mapping notation. To write a function in mapping notation, simply replace f of x with f colon x. Also replace the equal sign with arrow. For example, so we replace f of x with f colon x, and we replace the equal sign with an arrow. F of x equals 2x plus 3 can be written in mapping notation as f colon x, arrow, 2x plus 3. Function notation can be used to solve word problems. Let's look at a word problem. The temperature at the surface of the Adriatic Sea is 24 degrees Celsius on a hot summer day. A researcher discovers that for every 5 meters he descends, the temperature drops 3 degrees Celsius. What is the temperature at a depth of 15 meters? So we know that the temperature at the surface is 24 degrees and it decreases by 3 degrees every 5 meters. We want to know what the temperature is at a depth of 15 meters. First, model the water temperature using function notation. Then substitute 15, the depth, for the independent variable to find the dependent variable, the temperature. So first, we model the temperature using function notation. Then we're going to substitute 15 for the independent variable to find the temperature. Let D represent the depth in meters, and let F represent the temperature in degrees Celsius. So we also always have a let statement. So we're modeling F, the temperature. We're modeling F, the temperature, as a function of D, the depth. F of D equals 24 minus 3 times D divided by 5. 24 minus 3, because 24 minus 3 divided by 5, because 24 is the initial temperature at the surface. It decreases by 3 degrees for every 5 meters. So we have to divide D by 5 to know how many drops of 3 degrees we have to reduce from 24. F of 15 equals 24 minus 3 times 15 divided by 5. So here we substitute x equals 15 into the function. F of 15 equals 24 minus 3 times 15 divided by 5, which is 3. So f of 15 equals 24 minus 3 times 3. F of 15 equals 24 minus 3 times 3. F of 15 equals 24 minus 9. F of 15 equals 15, because 24 minus 9 is 15. The temperature at a depth of 15 meters is therefore 15 degrees. Don't forget to write a concluding sentence. Always write a concluding sentence. And that's all for Lesson 2, Functions and Function Notation. Stay tuned for next lesson, Lesson 3, Maximum or Minimum of a Quadratic Function. Be sure to visit our YouTube channel, MyMathEducator, for great videos. And like and subscribe for more great math videos. Also, visit our website, www.mymatheducator.com, where you'll be able to access our paid text lessons for a fee of $29.99 a year. If you want the same lessons in video format for free, covering the exact same content, head over to our YouTube channel, MyMathEducator. And now, feel free to click on the element on the screen to access the full-length lesson